All right, so I think this is recording. Here we're given a function f of x, and we're asked to determine if the inverse is a function and to find that inverse. So let's start out by thinking about what this graph looks like. X squared, we know that this is a quadratic function and that the graph is a parabola. With the leading coefficient here, 6 being positive, it's a parabola that opens upward. And this is in vertex form. So I know the coordinates of the vertex are 4, 12. So a sketch of this graph is something like this for a parabola where the vertex is 412. But this is a little bit incorrect because it's saying that x is less than or equal to 4. So I need to, they've restricted the domain. Not because of the quadratic function. The quadratic function itself, yes, it could be all real numbers, but we're trying to restrict this, and the reason for that is because now this is not only a function, but it's a one-to-one function. It passes both a vertical line test to be a function, and it passes a horizontal line test to be a one-to-one function. You can't find a horizontal line that intersects that graph more than once. If I still had the right half of this parabola, it would fail to be a one-to-one function. So this restriction makes this function a one-to-one function. So it's only one-to-one functions that have inverses that are also functions. So when I do find this inverse, I know that it's going to be a function and that itself is going to be a one-to-one function. All right, so when we're finding the inverse, we go back to x and y notation. So instead of using f of x, I use y equals 6 times x minus 4 squared plus 12. And I know that the domain of this, it has been restricted to be less than or equal to negative 4, to be negative infinity to 4. And I can see that from my graph, you know, that it was given. So I had to, that's why I graphed it the way I did with the left half of the parabola. I can also see from this graph that the range of this function is all numbers that are greater than or equal to 12. So when you find the equation for an inverse, that you switch the domain of range. So everywhere we see a y, we replace it with x. Everywhere we see an x, we replace it with y. So we've also switched the domain of range. Now the range is negative infinity to 4, and the domain is 12 to infinity. So now what I want to do in order to find the equation for my inverse, I want to solve this equation for y. So I'm going to subtract 12 from both sides. I'm going to divide everything by 6. I'm going to write my variable y on the left-hand side. All right. So when I go to solve this for y, when I go to take the square root of each side, I have to be a little bit careful here. Remember the y values, the range of this thing is less than or equal to 4. So y minus 4 is actually a negative number because you're to the left of 4. So when I go to take the principal square root, I know the result has to be 0 or positive. I'm going to have to put absolute value symbols around this. Now over here, maybe I should have, let's rewrite let's rewrite this with a common denominator. So I'm going to multiply this by 6 over 6. And I have x minus 12 over 6. Yeah. Oops. I want to shrink it, but not too much. All right. Well, like I say, I know that y minus 4, if y is always less than or equal to 4, I know this is going to be y minus 4 is a negative number. Well, the absolute value is a positive number, so I can drop these absolute values if I change the order of this subtraction. Y minus 4 and 4 minus y are opposites. If y minus 4 is negative, then I know that 4 minus y has to be positive. I'm going to rationalize this denominator. I can't have a radical in the denominator, so I'm going to multiply this by 1. So then this is 6 times x minus 12 all over 6. So I have, if I solve this for y, I have 4 minus the square root of 6 times x minus 12 all over 6. And everything is looking pretty good, because remember that we switched the domain and range. That we're saying the domain of this is 12 or larger. Well, that makes x minus 12 0 or positive, so I'm not taking the square root of a negative number. And my range here, I know, is from negative infinity to 4. All right. So since this was, we know that the original function was a one-to-one function. So now this inverse, I know it has to be a function, and I can come in and use my function notation and call it f inverse to indicate the relationship with f, that these are inverses of each other. And I have 4 minus the square root. And I don't think that I need to distribute that. I can just leave it like this. And of course, my domain, I have to tell people that, well, actually, I guess I don't have to tell people because it's implied by the square root, but I'm keeping that x greater than or equal to 12. So hey, I hope that helps. I'll talk to you later. Bye.